Hello, dear students. Welcome back for another exciting lesson. This one on introducing the law of sines. Oh yeah. Okay, when can we use the law of sines? Well, we know that Pythagorean theorem, sine, cosine, and tangent, is only for right triangles. The really wonderful thing about the law of sines is that it's for any triangle, including right triangles, but any shaped triangle at all. All right, and later on we'll learn the law of cosines, and that is for any shaped triangle as well. All right, so let's get right to it. What is the law of sines? It's this funny looking formula that you see here below. Um, and the way you use it is if you need a problem, if you have a problem where you need to find a certain side length of the triangle or an angle measure of a triangle, you can probably use this formula to figure it out. Now, let's take a look at this formula a little bit more detail. In just a bit, sorry. First, we need to talk a little bit about how triangles are labeled. So, if I have any shaped triangle and I call the angles A, B, and C, notice that they are always capitalized, A, B, and C. And then the sides, if I want to know the length of the side, I can call it lowercase a, b, and c. And lowercase a is always opposite of capital A, lowercase b is opposite of capital B, etc. Okay, so capital letters for angles, lowercase letters for side lengths. Okay, I'm sorry. Back to the formula. Notice in the original formula up at the top that there are two equal signs. Well, that's not really an equation. You can't really use it the way it's written that way. It's just a shorthand way of writing three separate equations all in one. So on the next line you'll see three separate equations where all those ratios are all equal to each other. Alright, and occasionally the bottom equation you'll see this as the version that is written as the law of sines in some books or on some resources on the internet. And it is exactly the same thing as the one up on top. Remember when we study proportions, we can take these proportions and flip them upside down and it'll still give us the same result, and that's what's going on here. When you do the cross products, you still get the same cross products writing it either way. So we're going to use the top version rather than the bottom version. Okay, let's jump right into our first example problem so we can see how this works. We're given a triangle, and in that triangle, angle A measures 40 degrees, angle B is 88 degrees, and side A, which is opposite of angle A, is 15 units. And our challenge is to find the length of side B. Well, they don't give us a picture, and so that's the first thing that you should do. So draw a picture and label it, and since it can be any triangle, you can just draw basically an equilateral triangle, label the parts, and then go ahead and substitute the values that you know into your picture. Okay? The next thing you have to do is substitute the values into our formula. Well, the way the formula is written right now, the law of sines formula, it's not usable. What we have to do is we have to take out the elements that we need. So we'll go ahead and change the law of sines and we'll simplify it to this much because we don't know anything about C. So we'll take that part out. So now we have the sine of A over A equals the sine of B over B. Alright, this we can use. We'll go ahead and substitute our values in, and you see that we end up with a proportion that we can actually solve. We're gonna solve for B. And so from this point on, it should look very familiar. You cross multiply, you get B sine 40 equals 15 sine 88, and then you go ahead and solve for B by dividing both sides by sine of 40. Now I put in the next ratio with all the parentheses because sometimes with your calculators it's tricky to type in the information correctly and get the right answer. You never know when you hit equal sign, you never know if that answer is the right answer. So by being careful, by putting parentheses around the numerator, parentheses around the denominator, you'll guarantee that, not guarantee, you more than likely will get the correct answer. In this particular case, B is about 23.32 units. Okay, let's go on to the next example. In this example, we're given that angle A is 47 degrees and then two side lengths, and we're challenged to find angle C. Okay, so again, draw a picture, any shape, any triangle, label it, and then once you've labeled it, you're going to want to take a look at the law of sines and figure out which ratios you need to use. We don't have anything about B in there, so we're going to take that part out. So we got the sine of A over A equals the sine of C over C. We're going to go ahead and substitute our values in and cross multiply as usual, right? So cross multiply and then follow through mathematically, all right? And you should get about 30.4 degrees, all right? Now there is a tricky step here. Some people want to divide both sides by 13 sine when they want to isolate C, and you can't do that because you can't separate the sine from the C. So you have to do this in two steps. Divide both sides by 13 and then inverse sine. So please look at that a little bit more carefully. And here's your final example, example 3. All right, solve the triangle. Well, solve the triangle means find all the missing values. That means angles and sides. So any angle or side that isn't already given, we're going to have to figure them out. Okay, so again, there's our triangle, there's our values. We're going to go ahead and immediately we should see that angle C is 52 degrees, piece of cake. All right, now we need to figure out some side lengths. So you use the law of sines to figure out, in this case we solve for side B. We already did that in example 1. So what we'll do when it comes time to is now we have to find side C. So we do law of sines over again. You find that sine C is 18.39 and you're good. You have solved the triangle. You found the missing values. Okay, so now how do you know when you have a law of sines problem? This is going to be more of an issue later on when you learn law of cosines, but for right now I'm going to give you a heads up. In the first and third examples, you were given a problem where you were given two angles and one side length, and sometimes that side length is in between the angles, sometimes it's outside. So you may be given an angle side situation or an angle side angle situation. Both of those use the law of sines. Okay, now in this particular case you were also given in example 2 a angle side situation, and we know that there is trouble whenever we deal with angle side. So in this case you may have no solutions, one solution or two solutions. It's very sophisticated trigonometry stuff that you'll study in algebra 2. For us in geometry, we'll only do the one solution. Okay, and that's going to be it for this part of the lesson. Thank you.